I wish there was some prize I could give to the party who stays to the end.
Oh, yeah.
We were supposed to start the next primary talks now. Again, provided Dr. Tom. Title is Renewable Generator Load Controller. The sponsor is Seattle City Light. This is their sponsorship. This is the second project that this is sponsored.
My name is Jeremy Roth, Cole Purbaugh, John Fernandez, and Will Carson, and we are Team Renewable Generation Load Controller. As the name suggests, our focus is on renewable generation. A little background that in 2007, Washington State passed a law that required that the public utilities in the state would source 15% of their electricity from renewable sources. Of the available renewable sources that we have in the state, solar and wind are the most unpredictable and difficult to account for. And to clarify, for the scope of this entire project, the only data set that we had available was wind data, and that was made available to us by Bonneville Power Administration, so all of our focus was done solely on that. Because wind and solar are difficult to modulate, and their nature is dynamic, utilities are going to have to rely on expensive backup systems in order to meet for supply or demand to meet supply. So when this generation data fails to meet forecasts, the utilities having to turn on these backup generators is costly, and it's inefficient and expensive. And that's not what we're after. Our Seattle City Light sponsor, Michael Pezzin, challenged us with making a device that could dynamically respond to these changes in generation. Not only does this concept line up with their new slogan of being the nation's greenest utility, but it's a solution to a problem that utilities face every day. In order to meet the challenge presented to us, we had to create a device that could respond to these dynamic changes. And in turn, take this reduction command and send it to an appliance and reduce power consumption to match the generation curve. Initially, we asked ourselves, how could we do this? We decided on using discrete switching techniques in pulse width modulation. And once we decided that, the next thing we had to figure out was what type of residential loads could handle our discrete switching and pulse width modulation and not be harmed. With the help of our faculty mentor, Eric Sortone, we decided to focus on thermostatically controlled resistive loads. And I am not going to say that again in this presentation. So when we refer to water heater, space heater, load, that's what we're talking about. The benefits that thermostatic control, I lied, that these loads provide is that they not only can they handle our switching, they consume a lot of power, but they also have the added benefit of energy storage. And this will become important a little bit later. So the benefits that we foresaw for this project was we thought it would benefit the grid in several ways. Better load response, we make better use, more efficient use of our state's natural resources. And we can integrate them in the grid we can alleviate stress on the grid without taxing it too much. We can reduce the need for these backup generation sources. We can end up saving the utility a lot of money by having loads dynamically respond to change. There's no need for these. These could eventually be